Hello to one and all. Today, I, Netra, along with my team members, present to you a journey through the universe, the birth, evolution, inevitable end, and related theories. As you can see, the team behind this project consists of Aditi, roll number 4, Heeral, roll number 10, Neel, roll number 14, Rushang, roll number 15, and I, Netra, roll number 16. So the topics we are going to cover today is a brief introduction. Then we'll start off with the origin or the birth of the universe. Then we'll talk about the evolution of the universe and the composition of the universe, that is the particles and the energies and the matter that makes up the universe. Then we'll talk about some related interesting theories and paradoxes that we came across. And finally, the inevitable end and theories about the end of the universe, as well as a conclusion. So let's get started. The universe can be defined as all of space and time and its contents, including all the energies and matter such as stars, galaxies, planets, and any celestial bodies that you can think of, all are encapsulated within our universe. Universe can be said to be a totality of our existence. That is, it contains everything that ever existed, everything that exists right now, and everything that will exist into the future. So the universe is a pretty vast concept, right? Its size is unfathomable and its mysteries are still mostly unexplored. Many scientists and people alike have tried to understand and explore the depths and the mysteries of the universe. One of these sciences that studies the celestial bodies and phenomena is called astronomy. So astronomy can be classified into multiple branches or parts like observational astronomy or theoretical astronomy, but the main subfields are as follows: planetary astronomy, galactic and extragalactic astronomy, stellar astronomy, and cosmology. So, planetary astronomy, as the name suggests, studies different planets, comets, meteors, while stellar astronomy, as you guessed it, studies stars, and right from their creation to their death, it studies all of these stages. Galactic and extragalactic astronomy study Milky Way and other galaxies around us that will help in studying the motion and the interaction of these galaxies with each other. And finally, cosmology is a science that studies the origin and evolution of the universe as a whole. According to NASA, cosmology is defined as the scientific study of the large-scale properties of the universe as a whole. Multiple cosmologists, that is the scientists who study this subject, have puzzled over interesting concepts like string theory, dark energy and dark matter, and the possibility of a multiverse, that is multiple universes. There are different types of cosmology, as you can see here. There's religious cosmology, physical and philosophical cosmology, and modern metaphysical cosmology. Religious cosmology or mythological cosmology has its roots based in beliefs that are based on traditional, mythological, religious, and arcane literature, as well as traditional myths about the creation and the origin of the universe. Physical and philosophical cosmology is studied by scientists such as astronomers and physicists, as well as philosophers of time and space. Due to the shared scope of this, the physical cosmology consists of theories that are based on scientific as well as non-scientific propositions, and some assumptions cannot be quantifiably tested and proved. Modern metaphysical cosmology is mostly dominated by the Big Bang theory and the lambda CDM model, which is the widely accepted model. It tries to bring together concepts of observational astronomy as well as particle physics together to lead to different widely accepted models such as the lambda CDM model. So, cosmology as a whole tries to understand the origin and the evolution and the end of the universe. It tries to answer questions such as what is the purpose of existence, why was the universe created, how was it created, how do we know the things that we know, what is the final fate or the inevitable end of the universe if there exists any, what is the material composition of our universe. All of these questions, most of them are still unanswered, and most of these mysteries are still unknown and unexplored. Today, we will focus on the widely accepted theories for the origin, evolution, and end of the universe. We will look into the composition of the universe, that is, the particles, the dark energy, dark matter that comprises or composes the universe, as well as some interesting theories and paradoxes that we came across while researching. Now, let's move on to point zero, that is, the origin of the universe.
Hello, this is Heeral Dedhia, roll number 10, and I will be talking about the different theories related to the origin of the universe. The universe is everything, right from the tiniest of particles to the largest of galaxies, and the very existence of space, time, and life itself. But how did it all begin? The origin of the universe has been a great mystery over several centuries, and there have been many theories about the origin of the universe, like the steady state theory and the oscillating universe theory. However, the most widely accepted and the most famous theory of origin of the universe is the Big Bang theory. The Big Bang theory is based from an observation that galaxies move away from each other at a great speed over all directions, as if there was an explosive force amongst them. So let us explore what exactly is the Big Bang theory. The Big Bang theory states that the universe began from a hot and infinitely dense particle which was only a few millimeters in width, which was similar to a supercharged black hole. And about 13.7 billion years ago, this particle exploded. And it was this explosion which they call the Big Bang, which created the space, matter, time and energy, and all these things came into existence. Within the initial phase of this singularity, it was extremely difficult to distinguish between energy and matter, as at those high temperatures we could not differentiate between them. But within a few seconds of this explosion, there were particles of energy and matter released at very high speed, a speed which approached to the velocity of light, which is roughly around 300 million meters per second. So you can imagine the speed of these particles exploding, and later they got isolated and eventually they turned out to those entities of matter and space. In the past century, there has been an extensive research about finding evidence for the Big Bang theory and what all can be deduced from this. And most of the Big Bang theorists believe that the galaxies and the planets and the stars are still continuing to move in the explosive force away from each other and at a great speed. This supposition is supported by observing the galaxies and planets and how they move and what kind of radiations are emitted by them. So now let's dive into how this theory came into existence, the Big Bang theory. So a Belgian priest named Georges Lemaitre was the first one to propose the Big Bang theory, and in the 1920s he stated that the universe actually began from a singularity and from a single atom. This theory got major boosts when in the year 1929 Edwin Hubble had done this observation from Mount Wilson Observatory in California, and he concluded that all the galaxies which were observed by him were receding away from each other at speeds close to thousands of miles per hour. This strongly supported the Big Bang theory, and later on research was done which added more and more validation to the theory. In the later years, a glow of the cosmic radiation was detected from the Earth was another way of validating the Big Bang theory, as these were believed to be the remnants of the radiations of the Big Bang. The Big Bang theory is not complete in itself. It does leave a lot of questions unanswered, like what was the original cause of the Big Bang itself? Did that have a trigger or not? And there are various concepts of the Big Bang theory which yet are not predicted. But until date, this is the most widely accepted theory, and the universe is believed to have started from the Big Bang. I would now pass upon to Aditi Bhagwat, who will be talking about the evolution and the composition of the universe. Thank you.
I'm Aditi Bhagwat and my roll number is 4. Let us first talk about the evolution of the universe. Today, it is believed that a universe was created in a massive explosion that not only created the majority of matter but also the physical laws that govern our ever-expanding cosmos. So the question that arises is, how was the universe actually conceived from a massive explosion? Well, the answer to this question can be found out using the timeline of the Big Bang. It all began about 13.8 billion years ago, and during this time there were 4 periods of time that were extensively studied about. They were the singularity epoch, the inflation epoch, the cooling epoch, and the last one was the structure epoch. We'll talk about these one by one. Now, the singularity epoch was also known as the Planck time, and it was the earliest known period of the universe. During this time, all the matter was condensed on a single point of infinite density and extreme heat. Because of this, the state of the universe was highly unstable, and the universe slowly began to expand and cool down, which led to the manifestation of the fundamental forces of physics. The second period of time that we talk about is the inflation epoch. Now, after the first fundamental force of universe was formed, the inflation epoch began, which lasted from 10 raised to minus 32 seconds onwards. After 10 raised to minus 37 seconds, a phase transition occurred. Which led to the separation of forces, which further led to the universe growing exponentially. During this time, particle-antiparticle pairs were continuously formed and also destroyed in collisions, which led to the predominance of matter over antimatter in the universe. The third period of time is the cooling epoch. Now, after the inflation stopped, the universe only consisted of the elementary plasma particles, and after this point onwards, the universe only cooled down and the matter coalesced and formed. Scientists believe that 10 raised to minus 11 seconds after the Big Bang was the cooling epoch period, and during this time the particles' energy dropped significantly. Now, the last period of time that we talk about is the structure epoch. The name itself suggests that here during this period all the matter is going to take some shape, right? So during this period, slightly denser regions of almost uniformly distributed matter in the universe started getting more gravitationally attracted to each other, because of which they became more denser, forming gas clouds, stars, galaxies, and other astronomical structures that we see today, right? So this was what was in the structure epoch. Now let us go to what are the long-term predictions. Now, how will the future of the universe be? So there are some theories which suggest how the future will be, but before jumping into the theories, we must first know what the universe is composed of. So the universe basically consists of ordinary matter and elementary particles. There are mainly 3 types of particles which are present in the universe: the photons, the leptons, and the hardons. Now, the photons are basically the quantum of light, which have a 0 rest mass. The second one is the lepton. Now, a lepton is an elementary particle which has an half integer spin. Which has an half integer spin, and they do not have strong interaction forces. There are 2 types of leptons: charged leptons and neutral leptons. The last one is the hardons. Now, hardons are composite particles which consists of quarks, and they have very strong interactions between the particles. There are 2 types of hardons: the baryons and the mesons. Now, baryons consist of 3 quarks, and the mesons consist of 1 quark and 1 anti-quark. The last topic that we'll talk about is the energy and matter. So, our universe mainly consists of dark energy, dark matter, and normal matter. Normal matter consists of us human beings and other living beings. Now, the dark energy consists of about 70% of the universe, and the dark matter consists of about 25% of the universe. The remaining 5% is the normal matter, right? Now, the dark matter is the one which is keeping all the planets in the gravitational pull of the sun. And the dark energy is formed when the matter and the antimatter collide. Now they do nullify each other, but what they release is a huge amount of energy, which is called as the dark energy. In fact, dark energy will also be present where you're sitting right now in the empty spaces of your room, right? So this was all about the dark energy and dark matter.
Hi, I'm Rushang. My roll number is 15. So let's talk about the theories related to the universe. Since the beginning of the time, when man actually started to think, men became more and more curious about the universe, how it was formed, what it exists, how it looks like, etc. There have been many debates on theories like, is the earth round or is it flat? Does the black holes exist? Or and so on. And these questions have been in the mind of people since ages, until renowned scientists like Einstein researched and gave solid explanation for the questions and gave multiple theories. Let's look at some of the theories and paradoxes. So one is parallel universes and the other is infinite universes. So let's look at infinite universes. We don't know what the shape of space-time is exactly. One prominent theory that it is flat and goes on forever. This would present the possibility of many universes out there. But with the topic in mind, it's possible that universes can start repeating themselves because particles can only be put together in a finite number of ways. Parallel universes, going back to the idea that space-time is actually flat, the number of possible particle configurations in multiple universes would be limited to finite distinct possibilities. So with an infinite number of cosmic patches, the particle arrangements will eventually start repeating themselves. So that would mean that there is a cosmic patch that is exactly similar to ours. So there's a universes that would contain people like exactly like us existing in that universe. So there might be patches that differ by 2 particle positions, 1 particle position, and so down to patches that are totally different from what is ours. There are some few more theories about the existence of the universe and one of the theories is that we live in a computer simulation. This is a very far-fetched theory which suggests that we are living in a computer program of aliens, and that if they decide to delete any one of us tomorrow, no one will remember that the program existed, that the person existed, and its memories will be cleared forever. There is a high probability that we knew someone yesterday about whom we don't have any idea today because the person was deleted from the program itself. The other one is deja vu. Many of us might have experienced this. Going back to the theory of parallel universes, we seldom feel that we have gone through a certain series of events before or that we have done those things before. We usually shove it under the carpet by saying that it might be a dream or something. But it's possible that ourselves in another parallel universe went through the exact same events, did the same things, and hence we can faintly remember what the situation was like. This feeling is basically called deja vu. Another theory is black holes. We don't know how big our universe is, and there is a theory that there is a chance of multiple universes. So how to get to the other universe? Theory says that the black hole is kind of a wormhole that opens up in another universe. Now we know that once anything goes into the black hole, it no longer exists, it can no longer return. So it basically loses information connection from our universe itself. On the other hand, wormholes are warps in time-space. That's sort of a tunnel that are used to travel from one galaxy to another, as shown in many popular movies like Interstellar and also many of the Marvel and DC movies recently. Also, if you have seen the very latest Stranger Things, it has an upside down, a parallel reality kind of thing. So this is how black holes are.
Hello, my name is Neel Gada, roll number 14. Today I'm going to talk about two things: time paradoxes and the fate of universe theories. Let's talk about paradoxes first. So, what does a paradox really mean? A paradox is a contradictory statement in which there is contradiction to a particular statement and there is a contradiction to the fundamentals of the statement. Thus, you cannot prove whether the statement can actually exist or not. Let's talk about the first and foremost, the most important paradox, grandfather's paradox. So, what is a grandfather's paradox? Let's take an example. Suppose you envy your grandfather and you want to kill him. So, what you would do as a time traveler is you'd kill him before he was even born. So, let's do this. Let's be a time traveler. Let's kill our grandfathers before he's born. But now the paradox lies here. If your grandfather is not alive, then obviously you wouldn't be born. And this is a paradox in itself, that you are a time traveler and you are living. So thus you cannot kill your grandfather. Let's take another example, I think a very popular one. Let's kill Hitler paradox. So obviously people like us, we do not like Hitler for obvious reasons. The creator of World War, the dumbhead. Let's talk about Hitler. So we all want to kill him. To kill him, we have to go back in the past and then kill him before he was born. So if he's dead, then there would be no World War II. What a sigh of relief, right, for both of us. So if he's dead, obviously there'd be no World War. But then if there'd be no World War, there would be no reason to kill Hitler. There'd be no reason for me to go back and kill Hitler. And this paradox lies in itself, that if there was no Hitler, we would not have to kill him. If there was no World War, we would not have to kill Hitler. Let's talk about the third type of paradox, one of the very, very eccentric ones, the bootstrap paradox. So this kind of paradox is one in which there is a cycle formed. This is an irrevocable cycle. You cannot break the cycle. Here, one item depends on the other item, and if one item does not exist, there is no possibility of the other item to exist. I'll give an example for this. Suppose you are a scientist, and since you are a scientist, someone, we do not know the person, an unidentified person, he sends you a book, and in the book there are secrets of the universe, and there is a formula, the way how to make a time machine. You follow those steps and you make a time machine. Okay, so now you've made the time machine, and now we want to know who gave you the book. How did the book reach you? So what you do is you go to the time when the book was received. So here there's a cycle formed. If there was no time machine, you could not reach the book, and if there was no book, you could not make the time machine. So this is an entire cycle formed, and you cannot break the cycle. Let's talk about the other types of paradoxes. The two different types of paradoxes are arrow paradox and Achilles and tortoise paradox. These both are also known as Zito's paradoxes because Zito formed them. He questioned these statements. So Achilles and tortoise paradox. This paradox states that there was a race between Achilles and a tortoise. So the tortoise, obviously because it was slow, it was placed 10 meters ahead of Achilles. The speed of Achilles was 10 meters per second, while the speed of the tortoise was 2 meters per second. So it is obvious to our thinking that Achilles would overtake the tortoise in 12.5 meters. But there was a contradiction to the statement as well. So you can divide time in infinite sequences. So let's say Achilles moves forward to 10 meters. To travel 10 meters, Achilles would take 1 second, and in that 1 second, the tortoise would be 2 meters ahead of Achilles. So now to travel 2 meters, Achilles would take some other amount of seconds. Let's say he would take 0.2 seconds, right? And those 0.2 seconds, the tortoise would be 0.4 meters away. So can you see this pattern? If you divide time in infinite sequences, infinite moments, then Archiles could never pass the tortoise. He could never overtake the tortoise. However, this is a paradox in itself. Let's talk about the last type of paradox which we've mentioned here. That is the arrow paradox. Here, an arrow travels from one point to another, right? So, Zito says that an arrow does not produce any kind of momentum in small moments. Here, we're dividing time into infinite points. We are dividing time into infinite parts, and these parts are called moments. So Zito says that an arrow in these moments is stable; it does not move, and hence this entire situation where an arrow is moving from one stage to another, if the arrow does not produce any kind of movement in that moment, is entirely paradoxical. So these are the paradoxes that we discussed. These require a lot of thinking and a lot of energy behind this. Let's talk about the second part, which I'm going to discuss here. This is the fate of universe theories. So, what is the fate of universe theories? There are four possible fates. First is the big freeze, then is the big crunch, then is the big change, and the fourth and the last, the big rip. There are many other possibles, but these are the most popular ones. Let's talk about the big freeze. So we all know that a universe is comprised of galaxies which are comprised of solar systems. So what will happen in the big freeze is that multiple universes and one particular universe in particular will reach a heat death. So what would happen here is that everything, all the solar systems, all the galaxies would reach one particular temperature, and it would be so cold that no life could survive. It would be so cold that no planets, nothing would survive, and then this would result in the end of the universe. Let's talk about the second type of fate. The second type of fate is the big crunch. In this is opposite to the Big Bang. As we all know what the Big Bang theory is. In the Big Bang theory, the entire universe evolved from a small atom, a small mass. So what the Big Crunch theory says, that the entire universe will compact itself into one single atom, into one small mass. This is completely reversal of what Big Bang was. The third is Big Change. So in Big Change theory, what would happen? A vacuum bubble will be created in the universe. So this would transform space, and this would destroy the entire universe because of vacuum. So vacuum is a place where there's zero energy. So if there is any kind of disturbance in vacuum, then this could destroy the entire universe. The last kind of fate theory which you're going to talk about is Big Rip. So what is Big Rip? It is high density phantom dark energy rips which would tear apart the fabric of space time. This would happen, and the entire space time fabric that has been created over time will be ripped apart. So I'd like to continue by telling you from where these are the references from where we've taken information and from where we made this presentation, and you can take a look at them. And thank you for giving us this amazing opportunity to make a proposal to research about these things, and we really learned a lot from this project. Thank you.